Hello everyone. It has been brought to my attention that I did some arithmetic errors on some of the examples from Friday's lecture, so 4-3. It was in section 3, section 5, and section 6, example 2. I'd like to apologize. I had a couple of homework assignments due that night, and they were quite difficult, and so by the time I recorded these videos, my brain was mush. So again, I apologize. I'm not perfect. I'm human too, and so yeah, I make mistakes as well. And like I told you guys before, usually when we don't check our work, that's when the problems happen. And I obviously did not check my work, and I didn't check my lecture notes to see if I was right. So that was not good of me. So this video is I'm going to redo the examples how they should be. So let's start with section 3 example. And then one thing I'd like to say, and then you'll probably get an email from me, but since I can't give you guys presentation extra credit, I'm toying with the idea of if you guys watch my videos and you guys do see a mistake, I will give you 1 extra credit point towards your assignment, towards your homework, if you catch my mistakes. So that should be good incentive to watch my videos. All right, so now let's start with our example. So we are looking at the square root of 12 times 2 square root of 54. Right? So same process as I did in the video. I did mention, so if we rewrote this, 54, the square root of 12 times square root of 54. If we use the multiplication property right away, then we would have to multiply 54 and 12, and then we would have to find what number times what number equals this, or find the biggest perfect square. Still don't want to do it. I'm sure you guys don't want to either. So what are we going to do? We're going to simplify each square root first. So for the square root of 12, the first perfect square that goes into 12 nicely is 4. So I'm going to rewrite this as 4 times 3. And then for 54, this is where I went wrong. For some reason, I thought 9 times 5 was 54. That's not right, because 9 times 5 is 45. So the actual, what I should have wrote down the other day was 9 times 6. Right? So now, going on to the next step, so checking my work before we go on, 4 times 3, that is definitely 12, and 54 is 9 times 6. Now that my work is checked, let's continue on to the next step. So now we can use the multiplication property of radicals. So I'm going to change this into square root of 4 times square root of 3, and then this becomes square root of 9 times square root of 6. Right, and let's simplify. So for the square root of 4, the square root of 4 is 2, because 2 squared is 4. The square root of 3, this is as simplified as it can get, because there is no perfect square that goes into 3 nicely. For the square root of 9, this becomes 3, because 3 times 3 is 9. And then same with square root of 3, square root of 6 is also as simplified as it can get, because there's no perfect square that goes into 6 nicely. So now I'm going to rearrange my numbers so that they're with the like terms. So I have 2 times 2 times 3, and this is times the square root of 3 times square root of 6. Right, so 2 times 2 times 3, so 2 times 2 is 4, 4 times 3 is 12. Right, and then for the square root of 3 times 6, I'm going to use the multiplication property, but I'm going to go the other way. So instead of separating, I'm actually going to combine. So square root of 3 times square root of 6, this becomes square root of 3 times square root of 6. And why can I do that? It's because their indices are the same. Since there's no number here, the index for both is 2. Right? So now for 12, so what is 3 times 6? That is 18. Right? So let me bring my work up here. Right? So before we can say this is done, what do we have to do? We have to check this square root and see if it's as simplified as it can get. And then if we go through the list, we'll notice that it does have, the square root of 18 does have a perfect square that fits in nicely. What is it? It's 9. 9 times what is 18? 9 times 2 is 18. Right? Oops, what did I do? All right. So now, using the multiplication property again, this becomes the square root of 9 times square root of 2. And we know the square root of 9 is 3, so I'm just going to write 12 times 3 square root of 2. Right? For this, I use this property, but I just skip that step. Right? So now, lastly, we still have to multiply this. So what's 12 times 3? 12 times 3 is 36. The square root of 2, there is no number, there's no perfect square that goes into 2 nicely. So when I say perfect square, I mean I'm looking at the root 2 and up. So yeah, so 0 and 1, we don't worry about. Right? So now our final answer is 36 square root of 2. Alrighty, now to section 5. So for section 5, we want to multiply this, right? So let's go ahead and do that. So when we have this, we're going to distribute. It's the exact same as if we had like 3 times x plus y. What do? We're going to distribute the 3x to both terms, right? So when I multiply the square root of 3 by the square root of 14, I get the square root of 3 times square root of 14. And then for over here, square root of 3 times 4 square root of 3, that is square root of, I'll just write it like this. Right? And now let's just simplify it. So I don't know why I thought 3 times 14 was 52. Obviously in my head, I thought 3 times 4 was 24. I don't know. But what is 3 times 14 actually? It is 42. So, which actually makes our problem a lot easier. And then over here, this becomes 4, and then square root of 9. Right? I think maybe I skipped too much. So over here, I'm gonna squeeze. How did I get 42? I did 3 times 14, and this becomes 4, and then 3 times 3. Right? And then when we multiply that, we get this. Right? So when I look at the square root of 14, right, and then on your list of perfect squares, I don't have it with me, but when you go through that list, like 4, 9, 16, any of that, 25, 36, you'll notice that 42 does not have a perfect square. Does not have a perfect square that goes into it nicely, and 42 is not a perfect square itself. What does that mean? The square root of 42 is as simplified as it can get. Right? And if you don't believe me, take some of them. So if you do like 25 and then 42, and then you can also do 16 and 42 divided by 16, 42 divided by 4, and then you'll see that you'll always get a remainder for these options. So there's more that we could do, like 36. Right? So I'll let you guys do that on your own. So now let's look at the 4 square root of 9. So what's 4 square root of 9? So 4 times square root of 9, the square root of 9 is 3, because 3 times 3 is 9. One thing I did mention in that video is that if you notice that they have the same index and the same radicand, it's just the number itself. So if I have the square root of x times square root of x, that is just x. In this case, our x is 3. Right? So if you wanted, you could have just gone straight to here. So now we're almost done. So we already established that the square root of 42 cannot be simplified. But 4 times 3, that is 12. And this is the actual answer to topic 5.